right, everyone. It is the top of the hour and time for us to go ahead and get started. This is our Central Time Zone Lunch and Learn webinar to our Central Time Zone Condusiv customers. We'd like to say welcome. Thank you for joining us today. I hope that everybody is getting situated with their lunch. I know that we have a number of different teams who are participating from across the Central Time Zone. A number of you in fact, have your entire team huddled around in a conference room, and hopefully you have received your lunch. These Lunch and Learn webinars are something that we do regularly, and we have a team dedicated to doing them. As you can imagine, the logistics can be a bit of a challenge, but one thing that we ensure is that everybody does get their lunch. So if for any reason you have not received your lunch by now, if you can, in the chat box on the right-hand side, you can send a private message to the host panelist, which is Condusiv Technologies. You can send a private message to them. They're sitting on the edge of their seat waiting to hear from you and to resolve any situation where you may not have received your lunch. If anyone hasn't received their lunch, typically it's because there's perhaps a security guard hold up at your location. They may have difficulty getting through and getting that to you. So my name is Brian Moore, and I'm the head of marketing here at Condusiv. And with me on the Condusiv side is our senior vice president of product management and marketing, Robert Woolery. Robert, good to have you here today.
Thank you.
And we also have with us our highlighted featured speaker today, which is Arun TANJA with TANJA Group, analyst firm. And Arun, you've been doing this just for a couple of years, haven't you?
Yes, I guess you could say that.
Now, something I should mention before we go further, because I am going to hand it over to Arun here shortly. We like this to be an interactive webinar, so we have come with a preset content template to deliver. But should you have a question as the webinar goes along, we like these to be as interactive as possible. So if you look at your screen over on the right-hand side on the bottom right, you'll see a Q&A box. So if you can, just as the webinar goes along, type in your question or comment in that Q&A box. Make sure that you do not send it as a private question to one of the panelists because I'll be the one that's fielding those questions. So just make it an open-ended question to all panelists. So we are sure to all see it, and we will bring up your question as we go along. If we don't get to your question as we go through the presentation portion of this, when we reach the end at the bottom of the hour, we will move to a full Q&A session and stay online to make sure that everyone here gets their questions answered. So at this time, it looks like we have about 165 Condusiv customer accounts who have joined in with us. 164, and that count is going up. So at this time, what I'm going to do is I'm going to hand it over to Arun. Arun, with TANJA Group, has been deeply entrenched in one of the industry thought leaders, particularly on the storage side. And TANJA Group always seems to be just a step ahead of other analyst firms when it comes to identifying market trends taking place out there. So Arun, it's great to have you today, and I know that you're talking to our audience today on why hardware for VM performance should be your second option. So Arun, why don't you go ahead and take it from here?
Thank you very much, Brian, and welcome to everyone. Good afternoon. As you can see, the topic is why hardware for VM performance should be your second option. It's kind of a backhanded way of saying that you shouldn't necessarily throw hardware at the problem at the first sign of trouble. Maybe that was the way that you handled issues yesterday, but there are certainly options available today that are more efficient and do not necessarily require hardware. So that is what we're going to be basically focused on today. So with that, let me take you to the next slide. Just a little bit about who we are. Most of you probably have heard of us or read our materials. We are a premier boutique industry analyst firm that is really think of it as covering storage and all forms of virtualization, big data, cloud, WAN optimization, and really think of it as any data center infrastructure technologies. We have an interest in all of those to make sure that we understand the full data center. My team is pretty much all made up of individuals that have decades of operational experience. In fact, that's a prerequisite to be at the firm. And I'm fortunate to have a bunch of very, very strong individuals with lots and lots of operational experience, typically in engineering or marketing or both. What do we do? As I mentioned, we focus on technologies and best practices related to building and managing physical and virtual data centers and clouds. Our specialty happens to be emerging market analysis. We seem to kind of gravitate towards that because of our backgrounds. We do a fair amount of technology validation when vendors want to make a very large statement that they do something significantly better than others. They typically come to us and ask us to validate that functionality. So we do have a lab that we use for that. And of course, we spend a fair amount of time on end user research and write significantly on thought leadership issues relating to the technologies that I just mentioned. Let's go on to the next slide here. So really, let's look at what's happening to applications. My thinking is they are so much under attack today from so many dimensions. We've not seen that type of an attack ever in the past, certainly not in the past 3 decades. So why is that? Well, first of all, there's I/O explosion or data explosion from every direction that you can imagine. You've heard about the 3 V's, the volume, velocity, and variety. So we're under attack from all 3 dimensions. The volume of data easily growing at 30 to 60% a year. And I certainly know of many, many situations where your data is growing at 100% a year. But it's not just the volume of data, it's the velocity with which it's coming at you from different directions. And thirdly, it's the variety of data. It's not just the stuff that we use to input into our databases anymore. There's a variety of data that we've unimaginable a few years ago. I mean, there's audio data, there's video data. I mean, look at all of the amount of video that's being used in the enterprise situation. I'm not even talking YouTube. That comes in from the social media side. Then you look at all the machine-generated data. A single flight from New York to Tokyo, for example, or San Francisco to Tokyo, generates literally tens and hundreds of gigabytes of information that is all machine-generated. And maybe yesterday we had a luxury of not using that information. Moving into tomorrow, there's no question there is a ton of valuable information in that log data, so to speak, and we have to harness it. But before we can harness it, we have to store it and move it. Therein lies the storage challenge. Internet-based data, another huge. I mean, I don't have to say anything more about other than what's happening with e-commerce and all of the internet-based data that's been generated and collected by companies like Facebook and YouTube and so on and so forth. Mobile data, the same thing. Look at the amount of data that we're producing via cell phones and so on and so forth. That has to be kept somewhere and utilized in some fashion over time. Social media, and then of course cloud is exasperating that particular situation even further. So tons of data coming in, and of course data implies I/O, and we'll talk about that in a moment. The other factor that's exasperating the situation is the fact that server virtualization has come into our vocabulary over the past 10, 12, 13 years, and it is a godsend in the sense that it does help us to consolidate servers. It has made application provisioning a very simple task, and the mobility of applications. There's a whole variety of things that server virtualization has brought to us. But server virtualization has broken storage badly, and I'll show you a picture in a moment that shows that, puts a little light behind that statement. And if that wasn't bad enough, higher business expectations, the business units are expecting you to deliver more, faster, and in spite of the fact that there's the three V's attacking you from all dimensions. And at the same time, oh, by the way, the budget is only going to go up by 5%. You got to make all of this thing happen within that very narrow growth on the budget side. So yesterday's technologies really can't solve that problem that we're experiencing today from an application perspective. So I thought before I would go into some of the reasons and that all that stuff is happening and some of the solutions, let's look at the anatomy of an I/O. Vendors throw terms like latency and throughput and variety of other factors, and so we really need to make sure that we fully understand what these terms mean. So let's start with the basic. An IO command is needed to read or write something from an external device. In the world that we're living in, that means it's a hard disk drive or an SSD or some form of a disk drive. So anytime you need to get something from that or write something into that device, you need an I/O command. Now, hard disk drives can produce a limited number of these blocks of data transfers, if you like. And there's a concept of small block and there's a concept of large block. Typically, a small block is a 4K block. And when we're talking about transferring information in 4KB chunks, we typically want to look at the efficiency of that system in terms of IOPS, or input-output per second. And however, if the large block transfers have to be done, 64 KB or larger, all the way up to 64 megabytes, which is what Hadoop uses, for example, then in that case, the IOPS become less important because one IO is going to deliver a large amount of transfer of data, and so in that situation, we think in terms of throughput, and that is typically measured in megabytes per second or gigabytes per second. So a mechanical device has limited number of IOs that it can deliver at the 4 KB level. That's the key thing for us to remember. A fastest hard disk drive today, a 15K RPM fiber channel or a SAS disk drive, only generates about 100 to 200, approximately, let's say 150 to 200 IOPS. That's it. No matter what you do, that's all you're going to get from a single disk drive. Now, keep in mind that I/O bottlenecks can originate not just from storage, but they can originate from storage controller or from a network or somewhere else in the systems. Even though hard disk drives are typically the number one issue, but the challenge for a system designer is to really get the maximum number of IOs to reach the application by making sure that the entire path between the hard disk drive and through the system storage controllers and through the pipes that go through the switches and so on and so forth, that they are as well balanced as one can produce. I mean, that's typically the systems challenge. But the hard disk drives are typically the problem in that particular situations. So now the other thing I want you to keep in mind is application performance not only improves when you give more IOs or put in a storage system that generates or can deal with more IOPS. There is another concept of not creating too many IOs. So by reducing the number of IOs, and we'll talk about when that comes into play, you can also improve application performance. So, you've seen this, you've heard about this I/O gap that is being increasingly getting bigger and bigger and bigger. And let me tell you what, just in a nutshell, what's been going on. Just look at the speed at which CPUs have gained performance, but from Pentium 4 to Pentium D to Nehalem, that's a 15x growth. This is approximately from 2000 to now, and the time frames are not exactly marked here in these three columns, but networking in that time has grown 100x, whereas storage, particularly from a seek perspective, has only gone up 1.2 times. In other words, it hasn't gone up at all, and therein lies the problem, is that the servers and the networking and, by the way, the bus bandwidth and the memory speeds have all followed this upper path, whereas the storage has followed the lower path, which means that the I/O gap has continuously increased. In fact, I/O path has increased over the past 3 decades. There's no question about it. And it just keeps getting worse and worse and worse. So how do we deal with that situation is the question, and that's what we're going to wrestle with today. So I mentioned that server virtualization breaks storage. Here's a very quick, simple way of looking at it. Now remember, instead of running one physical machine with one application and providing storage to it, where you could fine-tune that storage, now you have many virtual machines. In the left server, there's 3 virtual machines running with a hypervisor, and there's 4 virtual machines in the second server. All of these virtual machines, obviously, by definition, need some storage. So you map that to the NAS and SAN storage that's shown at the bottom. Well, think about what happened to the I/O pattern. Even if that I/O pattern was well designed for between a physical server and storage before, by the time these 7 virtual machines generate the I/Os and put it through this so-called I/O blender, you have nothing but a randomized I/O pattern that is being seen by the storage unit. And so this is why storage becomes a huge bottleneck, and it is usually an IOPS issue, because this is a classic IOPS issue. It's a number of I/Os that are very constricted. Flash could not have come at a better time, no question about it. You can look at this diagram that shows IOPS on one side and latency on the other side. By the way, each of these things go up by a factor of 1,000. So this is not a linear chart. If I did a linear chart, you need a massive scale to show it. So there's in terms of latencies, you look at CPUs. The number of IOPS generated by a CPU, obviously, is capable of huge, in the million IOPS to a trillion IOPS type of capability that's built into the CPU side of it. And then you have DRAM, which is more in the mid-range there. You can see, whereas CPUs can work in picoseconds or nanoseconds, DRAM is typically in nanoseconds. And then you look at HDD, which really, if I'd done it on scale, would have been way down somewhere, which is working in millisecond latency levels and only hundreds of IOPS. And you can see why this gap was there, and Flash, fortunately, sits right in the middle between HDD and DRAM. So no question that Flash is an excellent technology and couldn't have come in at a better time. The question is, do you always have to throw Flash at the problem in order to solve an application performance issue? And that is the question of the day. Now, how have we solved this problem thus far? There's a whole variety of ways that you've dealt with, and I'm sure you're dealing with this thing today. Let's look at some of these things. You can buy faster HDDs. You can go from 10K to 15K RPM fiber channel drives. But as I mentioned to you before, the number of IOPS is still in the hundreds. You can't get any more. That's it. 15K RPM is the highest a disk drive will go. And so, but you can buy them, and you can gain some very incremental level of improvement. You can buy more hard disk drives and spread the workload in a parallel fashion, and short stroke the the disk drives. I mean, certainly that's a way to do it, but it's a horrendously expensive way to do it. Not only in terms of capex, but you add up all of these disk drives that are being partially used, and you have just added power and cooling and space. And I mean, it's just a bad way to do it. Except maybe yesterday we didn't have any choice in the matter. Today we have several choices. You can add an SSD to an existing storage array. That's to put a flash drive because it doesn't take full advantage of flash. That is inherent in the flash technology. But you can certainly gain some reasonable amount of performance improvement, certainly by putting a given application data on an SSD tier. It's certainly an option. You can buy an SSD and buy caching software. There's a variety of solutions that have become available now that will use that SSD not as a tier but as a cache, and there are certainly advantages to doing that. You can buy a PCIe flash card and with an appropriate driver and put it in each server, and that certainly will accelerate your applications that are serviced by that particular server. You can certainly go all out and buy an all-flash array. There's a variety of them available in the marketplace. A very expensive way to solve the problem, and maybe for some applications that is the right way to go. But in my view, that is not necessary for a large percentage of the applications that you might have in your environment. You can certainly buy a hybrid array. There's a variety of them available in the market which use flash in its correct form, and they use hard disk drives for capacity, and that can certainly help in an application performance situation. There's even new HBAs, particularly from QLogic, which has flash built in onto the same HBA, and they can virtualize a bunch of HBAs, the flash portion of those HBAs across servers, and give you a nice pool of, it's actually going to be a caching software situation. Or lastly, you can buy an SSD and flash virtualization software. I'm aware of at least one vendor that does that, where you will buy SSDs, put it into servers, and this flash virtualization software will virtualize across a number of these servers. But keep in mind, all of these solutions require hardware purchase. And the question of the day is that always necessary? And here is that question: is there no way to improve application performance without buying more hardware? And the strong answer, no ifs, ands, and buts, is yes, there is, and that's what we're going to spend a little bit more time on. Let me just give you sort of the upper level statement on that, and about Condusiv's V-locity software product. It's a software-only solution that runs for either physical servers or virtual servers, and virtual servers is where the bigger application performance issue is, and it accelerates most Windows applications that would be running in those environments. It comes with a software called Benefits Analyzer. You run that software for 3 days. The first day it will run without the V-locity software incorporated, and it will basically gather information as a baseline as to how your environment is operating. And it will run the next day with the V-locity software, and obviously improve the performance. And then on the third day, it's going to gather all the reports and make all those reports available to you, so that you can see what type of an impact the V-locity software had. And then, of course, you're free to continue using it or not. That would be your prerogative. And the likelihood that there will be an improvement in all three dimensions, which is latency, response, and throughput, is highly likely. And by doing this, you may actually end up deferring hardware purchases indefinitely, possibly, or at least you can push it out by a quarter or two or three or four or whatever the case might be. And as we all well know, deferring hardware purchase is the same as saving money. And this particular product, and I've looked at it very carefully. This particular product is designed not to break any of your hypervisor services, vMotion types of things that you may want to do. They remain intact because of the place where this particular software operates from. So that is basically the message that I wanted to communicate to you. And with that, let me now pass the baton over to Robert Boulery, SVP of Product Marketing and Product Management at Condusiv Technologies, and he will take you through some of the more details of the product. So, Robert, over to you.
And Arun, this is Brian. I should mention shortly that after Robert gives this high level, and I want to let our audience know, we will be coming back to you for a few questions. So thank you. Robert, can you take over?
Perfect. Thanks, Arun. We'll go ahead and move into the next slide. So good afternoon, everyone. Hope you're enjoying your pizza. As Arun was talking about these bottlenecks, there's actually two primary performance barriers in this virtual world as well as physical world that contribute to the I/O explosion that Arun discussed. One of them is unnecessary write I/O, and the other one is unnecessary read I/O. Now, the first performance barrier, the unnecessary write I/O, is caused by the OS, the Windows OS in particular, breaking a single file into pieces upon write. Now, the challenge is each piece requires an additional operation on the storage layer. The net result of that is an I/O penalty occurred for every write and then obviously for every subsequent read. Now, the second performance barrier, which is unnecessary read I/O, is caused by the fact that a file can get read again and again. And with each read, the data must travel the full distance between the server, the storage, through the network, and that increases latency and steals storage bandwidth from your environment. We'll move into the next slide. Can we advance the next slide? There we go.
Oh, yes, of course. Sorry.
So, no worries. At Condusiv, we solved this problem with a new innovative architectural approach designed from the ground up for these high I/O environments, in particular virtual environments. Velocity, we have here, we're showing Velocity VM, that stands for virtual machine, but as Arun said, there's one also for servers. Velocity increases performance by up to 50% without any additional hardware being added to your environment. It does this by optimizing reads and writes at the source, the operating system. And by doing it there, it enables you to eliminate application bottlenecks before they even start, which allows you to accelerate the performance of your VMs as well as your applications. In essence, what it's doing, the bottom line is Velocity is reducing the amount of I/O you have to deal with, and it makes the remaining I/O far more efficient. Think about it as having more kilobytes per I/O. So we'll go to the next slide. So key to this I/O optimization is being at the top of the stack. Being at this location to perform I/O optimization puts us as close as possible to the application where I/O is created. Velocity is installed in the operating system of the virtual machine or guest as a very thin, lightweight filter driver. You can kind of think about this as kind of the meat in the sandwich. Being in this location, Velocity is completely agnostic to the application or to the storage. In fact, the application makes all the same calls to the OS as it normally does, and the storage sees a Windows I/O as it's always seen one. You can kind of think of it as an I/O is an I/O is an I/O. If a storage device or an application is compatible with Windows, it'll be compatible with Velocity. Now, Velocity works by providing intelligence to the OS on how to optimize read and write I/O, and then it lets the OS do all the work. Velocity doesn't change anything related to an I/O. So for a write I/O, Velocity provides intelligence, or you can think about it as a hint to the operating system not to break the file apart and write it sequentially, thereby removing unnecessary write I/O and speeding up the write, and then obviously the subsequent read when you read back that file. Now for read I/O, V-locity uses a behavior analytics engine that tells it exactly what blocks should be in cache and how long they should be there based on the application itself, frequency, and time. Now, other technologies, other server-side caching technologies, will leverage a predictive analysis approach. So the question you have to ask yourself, what is the challenge with a prediction? The answer is you can be wrong. So with predictive analysis, the way it works, it'll see that 5 blocks have been called up, and then it predicts that you'll need the next 15 blocks. Now the challenge is if the application doesn't need them, you just wasted 15 IOs. If this was the only instance of it, you'd probably say, who cares? But when you're running thousands of VMs and you're running millions of IOs, you can see how that can quickly add up and overwhelm your overall infrastructure. So with V-locity, it knows exactly what blocks the application needs, and it calls them up and holds them in cache for just as long as it is necessary. So V-locity ensures you not only have the right data in the cache, but it also ensures that you don't have multiple copies of the same blocks in cache, making that cache really efficient. So with V-locity's architectural approach, you reduce the amount of I/O your server, network, and storage have to deal with, and it makes the remaining I/O really efficient. I/O is optimized in the OS, making it very compatible with your existing infrastructure. It's a non-intrusive way to faster application performance. You can install it on the weekend, and come Monday, you're going to see faster application and VM performance, and oh, guess what? There was no performance tuning required because of the intelligence inside the product. So as we move to the next slide, it's kind of a quick pictorial on the benefits of V-locity. I like to refer to the image on the left side as the blender effect, where all the uncoordinated and random I/O traffic, much of it unnecessary, is all randomly tossed into the blender of the host, resulting in a chaos of I/O traffic that overwhelms the host, the network, and the back-end storage, forcing you to add more hardware to try to overcome some of these problems. As a result, you tend to spend an ever-increasing amount of money on hardware to compensate for this I/O traffic. Now, on the right-hand side, or on the other hand, is an image where V-locity has optimized the traffic. It's reduced the I/O traffic and made that traffic much more organized in terms of its patterns for both reading and writing. As a consequence, you're able to satisfy faster with less hardware your application requirements. It reduces your overall budget. It gives you a greater workload capacity in your overall infrastructure. And guess what? You'll run your applications much faster than you could before with this kind of technology. So with that, that's my comments in terms of it. I'd like to hand it back to Brian and Arun for questions that have been coming in here online. So I'll hand it back to you, Brian, and folks can ask Arun some questions.
Sure. Thank you, Robert. As mentioned, we will be moving into our Q&A portion of the presentation. We do have a few setup questions where we will be coming back to Arun and also fielding your questions that you may have for either Robert or Arun. We're happy to take those in. So if you look at the bottom right-hand side of your screen, the Q&A box, just make sure that you put in your question to address to all panelists. You can see in the screen in front of you, we do have the contact details where you can email either Arun directly. You can also email Robert directly if you have a further question or dialogue that you would like to engage directly with either of them. Also, as soon as this presentation is over, within the hour, you should receive an email from your Condusiv account manager, and they'll be sending you a copy of this presentation within the hour. It takes a little while for us to generate the on-demand link, and I know a number of you will be asking to share that on-demand link with the rest of your team and stakeholders within your company, and we'll make sure that your account manager gets that out to you as soon as that's generated, perhaps tomorrow morning. So, as mentioned, you've heard the message that with V-locity VM, 50% faster VMs, no hardware required. It's certainly a mileage will vary message, but it is what our customers typically see. So as soon as this webinar is over, if you want to engage your account manager and take a deeper dive discussion in this, or perhaps even do your own proof of concept evaluating the product in a dev environment, we're happy to get you connected to your SC and do that. We're at your disposal. So at this time, we're going to move to our Q&A session. And Robert, this first question is going to be for you. Now, this is a little bit different as we have our Central Time customers on with us. We have about over 200 Central Time customer accounts with us. But outside of Condusiv, not a lot of people have heard of Condusiv technologies, yet under the covers, Condusiv has been a major player in caching technology for years, even though perhaps some of our Diskkeeper customers are hearing this for the first time. Can you share with the audience why this is so?
Sure. So Condusiv's been doing software for over 32 years. Believe it or not, 12th oldest software company in the world. And through the vast majority of that time, we've had a close relationship with Microsoft. Obviously, when VMware came on the scene, we developed the same type of relationship. And the reason why that might be important to you, if you look at how we implemented our architecture, that becomes critical when you have that level of understanding. But as part of that, we also developed, as Brian mentioned there, a caching series of caching technologies. We've become an industry leader in that. 8 of the 7 leading manufacturers of compute platforms use a version of that technology, as well as some storage providers such as Western Digital and SanDisk. Over on the OEM side, you have Lenovo and Fujitsu and Samsung and Acer and Asus and a few others there that are in that. But if you look at that technology, you can kind of think of it in 3 areas. We have a RAM technology and caching. We have solid-state disk caching technology, and then hybrid, which will move data from a hard disk drive to either SSD or DRAM technology, and that's kind of what Brian was asking there, a little bit about that background.
Okay. Now, Robert, just as we're talking, we're getting a number of our Condusiv customers chiming in with questions. And in fact, a number of questions just popped in about pricing and about licensing. So just really quick, how is V-locity VM licensed?
Sure. V-locity VM as well as V-locity Server, which is for physical servers, both products are licensed by Physical Core. Obviously, there's volume license pricing available for your organization. We also do have a site license model available, and if you happen to be in a business model that requires hosting or a subscription model, we also have that type of modeling, that type of pricing model available as well.
And we're getting some questions jumping in from Diskkeeper customers, and it should be noted that if you're a Diskkeeper customer who is active on your maintenance agreement, there is a very generous migration path to get into V-locity. Isn't that correct, Robert?
Absolutely.
So, Robert, next question, and then Arun, we're going to come to you. Robert, you mentioned that Windows typically breaks a file into segments before it writes it to disk. Can you explain to the audience why does it do that, and how exactly does Condusiv keep it from breaking apart?
Sure, great question. So when the operating system takes a file, it looks out there and looks for the next available space, and then it fits as much of that file into that space as it can, and it keeps doing that until that file is completely written out to the storage system. As part of the challenge that comes with that is that you're now breaking that file up into pieces so you can fit it into each one of those available spaces. What our technology does is it provides intelligence to the operating system, and it tells the operating system that it needs to write this file in a particular length because we understand how big that file is, because our engine sees that information from the application. It sends that information that we see at the application layer down to the OS. It tells the OS to write that file out into the file size that that application wants. So it lays that data all the way out in a sequential write, truncates it off, and then reclaims or it captures back any available space that's there so that you have a very optimized write. Obviously, when you read that back, you're now going to go to only one spot and read the entire file back when you read it back.
Okay. We are getting a number of questions coming in, and I should mention, make sure you address that to all panelists, and if we don't get to your question this moment, we will get to it as we move further down in our Q&A session. So, Arun, this question is for you, and it's to help our audience understand exactly how the product delivers its benefit to their environment. Is V-locity processing I/O faster or is it enabling the system to process more data in the same amount of time with fewer I/O? And then you can mention, where does latency come into all of this?
Okay, fair enough, fair question. So, as Robert was just describing this, how the write is done, the fact that you don't split up the write, the file into pieces and then write each chunk with an I/O, because remember we talked about earlier, every time you want to write something, you got to do an I/O. So instead of doing 100 I/Os to write a file, if I just did one I/O because the file was not broken down, I just got a significant advantage in the speed at which I wrote them, because I wrote them, I'd write them now in a sequential fashion, and I can read them faster because I do that in a sequential fashion. So really, and so the latency is also affected by this, because remember, latency is I ask for something, how many microseconds or what have you before I get the result back. Well, if I'm going to ask for a file with one I/O and the whole thing is going to come back to me in one shot, it's going to be it has a positive implication on latency, because remember, if I did that with 100 split pieces, my total latency would be the sum of all of those I/Os, and which is obviously going to be significantly higher. So fewer I/Os, getting the same job done with fewer I/Os is absolutely the same thing as if I had a much higher IOPS engine, storage engine, to begin with. So that's the beauty of the system, is I don't need to throw hardware to get more I/Os. I intelligently reduce the number of I/Os I need to get the job done.
Super. Now, Arun, we do have some questions that are storage-related questions that are coming in. As you know, customers trying to optimize their environment to deal with their own I/O explosion. The question is, what if someone has a storage array with a few SSDs in them already? Does a solution like Condusiv's V-locity software still help application performance in that situation?
So, I think the short answer is yes, absolutely. Certainly Robert can pipe into this one as well. But if you have a few SSDs down at the array level, you can certainly use that as a tier for a particular application that is constantly very hungry and deserves an all SSD kind of a tier. But you've got a whole series of other applications that would be running in a classic virtual machine type of environment, where a solution like V-locity would actually be more than enough to give you the type of SLA that you want. So, but the net, these two things are complementary to each other. Having SSD does not mean that you don't need V-locity, and vice versa, of course.
Gotcha. So, Arun, essentially what you're saying is, due to the reduced I/O, that SSD is going to process more productive cycles than it would otherwise. You
got it.
So, Robert, I have a question here, and it's from John. He's asking, is anybody running this with Nimble storage? And as you know, we get a number of these questions that do come up about, is this software, is it compatible with whatever my storage device is?
It is compatible with any storage device in your environment. I guess what I should say is, if your storage device is compatible with Windows, it will be compatible with our solution. Currently, we have over 1,600 customers on the software platform since the first of this year, and they're running every imaginable storage system to it, as our CEO likes to say. It could be Nimble, IBM, EMC, NetApp. It could be Tupperware. It could be a bucket. It doesn't matter. If it's Windows compatible, it will be compatible with our product.
Okay. And Arun, before I come to you with another question, Robert, perhaps you can take this one for James. He's asking, is there a demo or trial that we can test before we make a commitment to purchase the technology?
The short answer is yes. The product has the ability to run a proof of concept or a POC where you could install the product, run it for as short as 3 days or as long as 30 days to evaluate the software. That's absolutely available. We've just put you in contact with our sales engineer to help provide that software and some best practices and some guidance in that process.
Great. Arun, a question for you. When looking at just the caching feature in Velocity, can you just take a look at the marketplace and explain how does it differ from other caching software available in the market?
Yes, absolutely. The caching software that's available in the marketplace, in all the cases I know of, presupposes that there is going to be some SSD. Whether that SSD or flash, I should say flash-based technology, SSD being, a drive that would go into the array itself. So, or you could have a PCIe card that goes into the server itself. So, the caching software in the marketplace just assumes that there is some hardware available to it, and it will cache using that particular flash technology. Whereas the Condusiv product that we're discussing here, the Velocity product, actually does not presuppose any existence of any hardware, and that's probably one of the biggest differences.
Okay, great, thank you. Arun, if I'm somebody who fits the profile of buying more storage hardware just to keep up with application SLAs, how does a product like Velocity impact how I should think about my performance strategy?
As I mentioned in my session there a little bit earlier, deferring hardware purchases is the same as saving money. So the concept here is put this software in, see what it does for you, see how much application performance improves, see if that improvement is large enough to really bring you back into whatever SLA is appropriate for that application that you've committed to downstream to your end users. And if that were the case, now you've just pushed out that hardware purchase maybe indefinitely. And so that's how I think I would visualize this if I were sitting in one of the IT shoes, if you like.
Okay, so Arun, basically it sounds like Velocity just may by itself in some situations meet the application SLA requirements, or in other situations, instead of them having to buy 50 pounds of storage, they may only have to buy 10.
Absolutely correct. I mean, any time that you take the, if you think of it this way, any time that I do something more intelligently at the application level, I de-stress the storage. Whatever storage I have, I de-stress it. In other words, I let that storage now work for other things where the IOPS might be needed, because I didn't absorb them for this particular application that had Velocity associated with it. So there is, there's a whole series of implications that come about from doing something simple like this, and clearly one of those things is that you reduce the pressure on existing storage and gave it additional longer life, and maybe allocated it to some other applications.
Okay, super. Robert, a question for you around installation. Ray is asking, is Velocity installed in each guest OS, or is it at the hypervisor level?
No, it's installed at each guest OS, as you phrase your question. So that provides you some very unique advantages in terms of the ability to easily vMotion, support any types of failover, things of that nature by having it installed there as opposed to having to manage all of that at the hypervisor level.
All right, and Leo is asking a question too, just about operating systems. What type of operating systems would we support? What type of hypervisors would we support?
Sure. So we're hypervisor agnostic. It works on Windows. It works on VMware's hypervisors. It works on Citrix, Linux, KVM. Those are all areas that people are using that product in today. In terms of the Windows operating system, anything XP going forward is supported by that product. What I get asked many, many times is, will you have a Linux version? That is definitely something that we're working towards. But I would like to just kind of remind you a little bit, if you think about it, is that even if you have Linux, a substantial amount of Linux in your environment today, if you're able to optimize your window-based VMs, think of them as well-behaved VMs by having velocity inside of it because they're reducing the amount of I/O that's going into the infrastructure, then those other VMs that do not have velocity will also see better performance because they're not contending for the resources because those resources have less I/O to deal with now because all the Windows-based VMs are much, much more efficient. So even if you have quite a bit of Linux in your environment today, having this product can absolutely help you in your overall environment.
Okay, super. I should note here we're 50 minutes into the presentation until we reach the top of the hour when we had planned to close, and we still have 150 Central Time customer accounts that are still online with us. So we'll go ahead and push through the rest of these questions and make sure that we do get to everyone. Arun, why haven't we heard about this issue of unnecessary I/O or seen a solution until now?
I think it's probably something, Brian, you or Robert can answer, certainly from a Condusiv perspective. But, these, well, I would say two things. One, I think it's always easier to jump at hardware to solve the problem because that's it's a simpler way to go about doing that. Solving it in software, particularly without any adjunct hardware, is a more difficult problem, and it requires, I think, the kind of skill set that you guys, your talent has had because of all the caching, expertise that Condusiv has had over the years. So, I mean, it really fundamentally comes, in my view, just comes down to that. It's simpler to solve it via hardware, and that's where majority of the vendors have gone. It's just harder to do it this way.
And I think to kind of piggyback what Arun said there, especially earlier on, the fact that other technologies found it easier to presuppose that you would just leverage hardware that sits out in the environment to gain performance, they go ahead and take advantage of that. Having a 32-year history in working inside the operating system, we know that very, very well, and we notice that there is a lot of opportunities to increase performance. As Arun said, the closer you are to the application and further up that stack and you do it more intelligently, it allows you to de-stress your hardware throughout your entire ecosystem. So taking this different approach that we took, by going as close to the application, the OS, we understood that you'd get that benefit of de-stressing not only your storage, but your network, your server, your memory, your entire infrastructure, where if we took the approach that other people have taken, we would just be contributing to that particular situation. And we just found this was a way that we could differentiate and make an impact immediately across a wide range of applications. You just didn't have what is you might consider the VIP applications, the only ones who get Flash or SSD. You could absolutely improve the performance of all your applications across your ecosystem, whether or not they were able to get SSD or Flash.
Now we have a question here. Is the product's main focus, is it on storage or memory as well?
What do you mean by that?
James, I think that perhaps what you're asking is maybe where the benefit of this product comes into place. I think
Okay.
the benefit certainly is going to be found on the storage side, utilizing server memory to do that.
Sure. So what you will see is benefit from a hardware perspective. You won't need as much server hardware. You won't need as much memory per se in those servers when you spec them out. You will absolutely not have to have a need for as much storage hardware for the obvious reasons Arun pointed out. If you have less I/O, you make that storage far more efficient with the I/O that it does receive because it's sent in a very efficient manner for those arrays. So you'll see some very big, where we see some of the biggest savings is in storage. The next area is memory and in the servers.
Okay, well, James just replied with yep, so.
We guessed right on that one.
Right. Now, a question from Kevin. He's asking a question which I believe that what he's asking here is around the data services on the storage device. Are we agnostic to those advanced features on that SAN or NAS, or are we going to, in fact, benefit them, like your thin provisioning, your deduplication, replication? How do we play with that?
Sure, and Arun can also jump in on this. We have actually a positive impact on all those advanced storage features. The fact that we optimize I/O right where it's created, what that means is that there's less I/O pushed to those advanced storage features. Those features now can focus on the I/O they do receive, and we absolutely send that I/O in a far more efficient manner so that we leverage, they don't have to work nearly as hard on processing that I/O because that I/O is very, very efficient. So we're highly compatible with all of those types of technologies, and if Arun, there's anything you'd like to add, please.
You know, Robert, my analogy sort of comes from something else that I've been harping on effectively now for a decade, and that is, data deduplication, is a hot buzzword these days. My thinking has always been that you want to do data deduplication at ideally at the creation of that data. In other words, reduce it down as close to data creation as possible, and then keep it that way. Keep it in a dehydrated fashion all the way through its life cycle. This is a very similar thing. You want to make the I/Os as efficient as you can at the earliest point in time, because that's where the biggest benefit is. Because all downstream stuff then takes advantage of that efficiency, and so it's basically just using that data deduplication as an example, Robert, to say what you said about the I/O part of it.
Okay, no, great answer, Arun. And Arun, I do have a question to come back to you with, but before I do that, Robert, a good question came in from a customer talking about the caching side of our solution. How much guest memory does V-locity use?
That's great. We recommend that you have 4 gigs of memory for your virtual machine, physical memory for that, for the use of our product. It can run with a minimum of 2 gigs of memory for that. Obviously, if you provide additional memory to us, we will be able to make your application run even faster, but our recommended is 4, our minimum is 2.
Now, is it a fixed usage that V-locity uses, or is this a dynamic cache?
It's a dynamic cache. So what happens is that V-locity will use the available cache. If it sees that the application needs more cache, and we will make sure that we back off so that application gets that cache memory. There's never a contention issue because of our engine. We see exactly when that request is coming from the application. We make sure that we step back before that request gets to memory. We also do that with CPU resources. We understand the balance of CPU resources with the application. If the application is going to need more CPU, we make sure that we throttle back so that there's no impact to the application.
Great. Now, Arun, a really important question here, and I'm going to speak hypothetically with you. If someone saw 50% performance gains from a 100% software approach that is set and forget, what would be some of the unique benefits to that?
Well, as we said earlier, Brian, it's if you get a 50% improvement in your performance, application performance, and I'm going to make the assumption that that 50% improvement is enough to bring you back into SLA compliance, whatever that SLA compliance is for you. That if you get back in that below that threshold, well then in that case, you just satisfied your customers downstream, and you did it without any disruption to the environment, without any purchases, without it's probably the easiest way to deal with something like this. Now, if the 50%, in your example, you said 50%, obviously the gain can be higher than that, or lower than that, depending on the application. So, really, it's like you try it. If it brings you back into SLA compliance, bingo, you stop there and you don't worry about buying any more hardware. That's kind of how I visualize this. And if it doesn't solve the problem, then of course go ahead and explore other ways of dealing with with that issue.
Now, Robert, it's been said when someone looks at Velocity that they're getting non-disruptive performance. Can you just explain what that means?
What we mean by that is the fact that your existing infrastructure as it sits, the servers you have, the applications you have, the storage you have, you don't have to make any changes to them. You don't have to touch them. Once our product's installed in there with its intelligence, it optimizes itself so it doesn't require any performance tuning. So from a standpoint, you don't have to touch your infrastructure from a hardware perspective or any of the hardware there. In addition, you don't have to do any performance tuning because the engines are doing it intelligently right when the I/O is created. So that's what we mean by non-disruptive. You can take your existing infrastructure, add software to it, increase its performance, and you frankly didn't have to do very much work to do that.
Great. Now, we are here at the top of the hour, and I do have questions that are still coming in, and should mention if there were any questions that we didn't get to, you can follow those questions up with your account manager. You also see Arun and Robert's email addresses. You can contact them directly if you want to continue the dialogue with them, so we can keep the conversation going. Robert, I will ask this last question from Tony. He's asking, how is this performance improvement measured? What objective tools would be used to measure it?
Sure, no, great question. So what we did in terms of this product is we've sent the product out so labs can look at it and test it. By and large, they've tested the performance of, the benefit analyzer and the way it measures performance against diameter and found the results to be exactly the same as what was reported by iometer. Some customers will do the same thing. They can absolutely run iometer at the same time and get some benchmarks and compare that against the benefit analyzer. That tends to be the widely used tool. Sometimes Perfmon is used as well. Something that we haven't discussed here is that in addition to all that, the company is so confident in the product that it's also provided a performance guarantee. So if you're getting, if you don't get 25% better performance in that environment, the software is free. Not very often does an enterprise-class software product provide that kind of level of guarantee and that level of confidence. So there's a couple of different things there to help you feel comfortable about the product and its capabilities.
Sure. No, great. Now, we're just past here the top of the hour, so we'll go ahead and close things out. Just a couple of quick questions. John had asked, do we need to do a reboot after an install?
Great question. So when you install the Velocity product, you can let it run without a reboot, but you will need to reboot to enable the server-side caching capability or the OS caching, read caching capability. All the other features run without a reboot. Just the read I/O optimization engine requires one. So you can install the product. The next time you have a maintenance window and you need to do a reboot at that time. When you're doing all your other Windows patches, you just reboot it at that time and off you go.
So we have a question. Can someone download the slides? And the answer to that is yes. Within the hour, you will receive an email from your account manager containing a link to the presentation. And as soon as the on-demand link is generated by WebEx, we will make sure that that is also emailed to you sometime tomorrow. A number of licensing questions have continued to come in over the course of the presentation. I think the best place for you to have that conversation is with your Condusiv account manager. You can engage them by email or by phone, but to reiterate again, it is price per physical core on the physical server. And if you are an existing DiskKeeper customer and you're looking to make the migration to V-locity to get accelerated performance in your environment, even though the product itself, V-locity, is a premium of services over the entry-level product DiskKeeper, there is a very generous upgrade path to get you into V-locity so you can use that in your environment. So Arun, we're just a few minutes past the top of the hour. A lot of great comments have come in from our customers, and they are appreciating the lunch, and we thank you for your time. Arun, do you have any closing remarks on your end before we close this out?
I think if my closing remark would be, try the simplest method that gets the job done, and the way I see it, I think this is one of the products that actually is a non-intrusive, simple way to try it out and see what you get, and then enjoy the benefits if it gets the job done for you, which is most likely will. So that's I think I'd wrap up with that.
Okay, Arun, well, thank you. Thank you for your time today. We'd like to thank our audience, our Condusiv customers, of course, for coming in and sitting in with us and engaging us. We would like to continue the conversation with you, and please reach out to your Condusiv account manager, and we thank you all. Have a fantastic day.